It's really getting uncanny. Some of these AI videos, you have to look twice, don't you?
Oh, absolutely. The realism is climbing incredibly fast.
And these AI talking portraits, the research we're diving into today, it feels like another big leap. Definitely potential for some aha moments here.
Hello there. Yes, it's quite something to see it all coming together, isn't it? Image generation, NLP, and now this super realistic animation,
Yeah,
making a convincing talking head from just one picture and some audio. That's been a tough nut to crack for a while. And this paper really brings some fresh ideas.
totally. You sent over fantasy talking, realistic talking portrait generation via coherent motion synthesis. Mengchao Wang and the team, it's dense. Definitely academic.
It is.
So our mission today, let's really get into the weeds. What are the core innovations? Why is this fantasy talking thing such a big step? We're focusing right on the academic heart, the really new stuff they figured out.
Exactly. This isn't just tweaking things around the edges. Fantasy talking introduces some fundamentally different approaches. But, to really get why it's innovative, we should probably look at what came before, the limitations.
Okay, good plan. Let's set the stage. What were the roadblocks with the older methods? I mean, people have been working on this for ages, right?
Oh, for sure. Yeah, early on, a lot of work involved building 3D models of the face, things like 3D morphable models, 3D MMs, or flame. The idea was basically create a 3D puppet
Right.
and then use the audio to pull the strings, make the expressions.
Makes sense conceptually, like a digital ventriloquist dummy almost. But where did that fall short?
Well, the main issue is just capturing subtlety. Real human expressions, the way we move naturally, it's incredibly complex. Those 3D models, even sophisticated ones, they often struggled with the tiny muscle shifts, the nuanced ways our skin deforms.
So kind of stiff, or maybe a bit artificial looking?
Exactly. Lacked that organic feel. Even with good models, getting that natural expressiveness was tough.
Okay, so then came newer stuff. The paper mentions diffusion models. We know they've been huge for static images.
Huge, yeah. And they offered a completely different way in. Instead of directly rigging a 3D model, diffusion models learn to build the video frame by frame, essentially reversing a noise process. You can get stunning detail.
Right.
But the first wave of diffusion models applied to talking portraits, they mostly zeroed in on one thing, lip sync.
Which is crucial, obviously. If the mouth is wrong, the whole thing tanks.
Absolutely critical. But that narrow focus sometimes led to other problems, didn't it?
Like what?
Like the rest of the person and the background being weirdly static. The paper mentions methods like anaportrait, echomimic, sonic, Halo-3 methods they compared against. Often you'd get great lip sync.
Uh-huh.
But the head wouldn't tilt naturally. The body was rigid. The background totally frozen. No coherent global motion.
Ah, okay. So the mouth is perfect, but it's attached to a statue. A very articulate statue, maybe.
Precisely. That's a great way to put it. That coherent global motion, the subtle head nods, posture shifts, maybe even slight background changes that happen when someone actually talks, that was often missing. And that's where fantasy talking really makes its mark.
Right. So how do they fix this? What's the core idea in their framework?
They start with a pre-trained video diffusion transformer model, a DT-based model, specifically 1.2.1. Using a transformer is key here.
Why transformers? Different from the usual units, right?
Yeah, transformers are really good at seeing connections over time, long-range dependencies in the video, essential for understanding motion.
Okay, for a strong foundation. But what's the main innovation they built on top?
It's what they call the dual-stage audiovisual alignment strategy, DAVIA. It's a two-pronged attack, basically, designed to get both the big picture motion right and the tiny details, especially the lips.
Dual stage. Okay, break that down. Stage one.
Stage one is clip-level training. Here, the model learns to sync the audio dynamics with the whole scene, not just the face, but the background, other objects, everything. The goal is coherent, global motion tied to the sound.
So if the audio gets louder or more energetic, the clip level training makes sure the head moves a bit more, maybe the posture shifts slightly, maybe even tiny background motions all kind of sync up.
Exactly. It's leveraging that DIT model's ability to grasp space and time, figuring out how the sound should influence the whole visual vibe across a short clip. It's about the broad strokes, the overall connection between sound and movement.
Makes total sense. Get the overall choreography down first. What's stage two then?
Stage two is frame level training. This zooms right in on the lips. They use a lip tracing mask generated with MediaPipe to really force precise alignment between the lip shapes and the audio, frame by frame.
Ah, okay, so stage one does the body and background. Stage two is the lip sync specialist. Why split it? Why not just do it all at once?
Well, the lips are actually a tiny part of the whole frame, right? If you only did the clip level training, the model might not pay enough attention to getting those tiny lip movements absolutely perfect. It might prioritize the overall scene motion.
Got it.
So the math guides it says, hey, pay extra attention here for sync. But they're clever about it. They use this probability factor, eta, to balance things. It forces focus on the lips sometimes, but not so much that it forgets about making the rest of the face look natural. Prevents over-optimizing just for the mouth.
That's really elegant. Balancing global flow and local precision. Okay, the paper also talks about a facial-focused cross-attention module for identity preservation. Sounds important for making sure it still looks like the original person.
Oh, absolutely critical. You need the person to look like themselves throughout the video. Now, older methods often used reference networks that looked at the entire input picture to keep the identity locked.
And I sense a but coming. What's the issue with using the whole picture?
The authors found it can actually make the movement too rigid. It's like the model gets scared of changing anything too much from the original static photo because it's constantly checking against the whole thing, so it restricts natural motion.
Right, that tracks. If you're trying to match every pixel, you won't want to move much. How does fantasy talking do it differently then? This facial focus thing.
Instead of the whole image, they zero in just on the face. They use insight face to find and crop the face, then arc face to pull out key facial features. Then they use something called a Q-former to align these features and create a compact identity embedding.
Like a unique ID code just for the face.
Pretty much, yeah. A facial fingerprint, like you said earlier. And by focusing only on preserving that facial identity signature,
Uh-huh.
it frees up the rest of the head of the body, the background, to move more naturally in response to the audio. It doesn't have those rigid constraints from trying to match the entire static image. It's a really key insight. Identity lives mostly in the face, so focus there.
That is smart. Preserve the face, let the rest move. Okay, one more module. Motion intensity modulation. What's that for?
Right, so people talk differently, yeah. Some are very animated, lots of expression, head movement. Others are much more reserved. This module is about giving you control over that intensity.
Ah, so you can dial it up or down. How does it figure out the intensity?
It analyzes the input data. It looks at the variance, how much things change in facial landmarks from media pipe to measure expression intensity. And it looks at a variance in body joints from DW pose to measure body movement intensity.
Okay, so it gets numbers representing how expressive the source is.
Exactly. Then it normalizes these into coefficients, basically numbers between 0 and 1. And these coefficients act as control knobs during generation. The module itself uses some MLPs, a ResNet layer, average pooling, technical bits, but essentially it feeds this intensity control into the diffusion process.
So you could make someone seem more energetic or more subdued than the original audio might suggest.
Potentially, yes, or just match the audio's intensity more accurately. Gives you that fine-grained control over expressiveness. Super useful.
Wow. Okay, so they've got this whole system. DAVA for the motion sync, facial focus for identity, intensity control. How did it actually do in tests? The paper goes into experimental validation.
Right, they tested it thoroughly. On tame datasets like HDTF, where things are more controlled, studio-like,
Uh-huh.
and also on a wild dataset they collected themselves, which sounds much more challenging. Varied backgrounds, poses, lighting, the works, real-world complexity.
And lots of metrics, those acronyms. FID, FED, SYNC-C.
Yeah, a whole battery of them. FID and FED, those basically measure how realistic the video looks overall. SYNC-C and SYNC-D check how good the lip sync is. Then there's ES for expression matching, IDC for identity consistency, does it still look like the same person, SD and BD for how natural the subject and background motion looks, and even an aesthetic score from real people.
So, really comprehensive checks. What was the verdict? Did it work?
It pretty much knocked it out of the park. On the tame dataset, Fantasy Talking got state-of-the-art scores on most things, especially FID, FED, the visual quality, plus identity, expression, and that aesthetic score. People found the results more natural, expressive, and just better looking. Lip sync was also really strong.
Nice. And on the tougher wild data set?
Even better, actually. It outperformed the others across all the metrics on the wild data. The authors reckon that's down to the DAVI handling the background variations so well, and the facial-focused identity thing holding strong even with challenging poses and lighting. Better sync, better quality, more natural movement, the whole package.
That's seriously impressive, especially handling the wild stuff. Did they compare it head-to-head with specific methods, like that Sonic one or Halo 3?
Yep. With Sonic, on motion intensity, they found it was similar for subtle, natural movements. But when things got more intense, more expressive, Fantasy Talking was better, likely because it considers the whole body motion, not just the head, like Sonic.
That whole body idea paying off again. And Halo 3.
Visual comparisons showed Fantasy Talking had fewer weird artifacts or distortions, the motion looked smoother, more natural, and the lip sync was noticeably better than Halo 3. The example videos in the paper really show the difference.
Okay. And they backed us up with user studies. What did actual people think?
They did, and people preferred Fantasy Talking, consistently. Better lip sync, better video quality, better identity preservation, and they especially liked the motion diversity, how natural and varied the movements felt. So the human eye agrees with the metrics.
Right. So wrapping up the technical side, these innovations, the dual stage alignment, the facial identity focus, the motion control they really seem to deliver. What's the bigger picture significance here? Why is this a landmark paper in this field, academically speaking?
I think the DAVA strategy is a really big deal conceptually, moving beyond just lips to syncing the entire scene with the audio. That tackles a core problem in a fundamentally new way. It's not just incremental improvement, it's a shift in how you approach the problem.
Yeah, fixing that talking statue issue fundamentally.
Exactly. And the facial-focused identity trick is also super neat, showing you can keep the person looking right without making them stiff. That solves a major trade-off that plagued earlier methods. It allows for that crucial motion flexibility.
And the intensity control just adds that layer of practical usability, especially for more dynamic, wild scenarios where people aren't just sitting still.
Precisely. It makes the output far more controllable and adaptable. Now, it's not perfect, of course. They mentioned limitations, right?
They did. Runtime was one. It's slow, which is typical for diffusion models because of that step-by-step generation process. They said accelerating it is future work.
Makes sense. Speed is always key for real-world use. Anything else?
They also pointed towards interactive portrait dialogue systems. Like, imagine having a real-time chat with an avatar generated using this tech.
Ooh, now that is a fascinating direction. Real-time interaction with something this realistic. Huge potential there.
Definitely. So, summing up this deep dive then, the key breakthroughs seem to be that dual stage audiovisual alignment for coherent motion and precise lip sync,
Right.
the facial focus attention for keeping identity without freezing movement,
Uh-huh.
and the motion intensity modulation for controllable expressiveness. Together, they make these talking portraits much more real, much more flexible.
Exactly right. It's how those pieces work together, tackling global motion, local detail, identity, and control that makes fantasy talking such a significant step forward. A really solid piece of academic innovation.
It definitely clarifies things, gives you that aha moment, seeing how they overcame those prior limits. So thinking ahead, as this tech gets even better, maybe even indistinguishable from reality, what are the big questions we need to ask about communication, maybe entertainment, how we see digital identity?
That's the million-dollar question, isn't it? The implications are vast. Think about virtual assistants, education, synthetic actors in films, but also, yeah, questions about authenticity, trust online, deepfakes. When AI can perfectly mimic not just appearance, but subtle body language and expression, how does that change how we interact digitally? It's something we'll definitely need to grapple with.
A lot to mull over. Well, if you, our listeners, want to get even deeper into the technical side, definitely check out the original paper, Fantasy Talking. Maybe look for their project page, too, if it's linked for visual examples.
Yeah, worth a look.
Thanks for joining us on this deep dive.
My pleasure. Fascinating stuff.
I can slide and die.
And you know what happens if I don't move on? More people die.